Hello, my friends. Welcome back to the Micromotor Workshop. We get free flight tips for the underdog. Today, I will be talking about 1S batteries. Okay, I think I've killed the feedback loop now. Reminds me of the old days where this happened a lot more often. So, this video was recorded and broadcasted live on Monday, 16th of April 2018, which may seem like the future to some of you who are watching this live. Okay, found the tab now. Let's start this again. This is the Micromotor Workshop, recorded live on April 16th, 2018. Now, this may seem like the future to some of you who are watching this live, but my clocks are set to Australian time, so we are ahead of quite a few of you. Today, I'll be talking about 1S batteries, and this recording will also be published as an audio podcast to complement my Micromotor University series. If you're interested in that, you may click the link that I've put into the video description. And there's also a link of another video that I already made about this topic, which pretty much explains the charging of 1S batteries, I thought comprehensively, but as it turns out, there are a lot more questions about this. So that's why I'm making this live stream and recording the audio of it to publish this later on iTunes. If you want to listen to the podcast version of this recording, you can search for Micromotor Workshop in your podcast searcher app of choice. If you're watching this live, as usual, you may participate in going to the link I've put on top of the screen, which further links you to the Discord chat room, which I'll be watching during the second half of this stream, and also to the forum where you can ask questions even if the stream is over. To kick things off, I'm going to read what I've prepared in text form for the Micromotor University. And if you have already read that, or while you're listening to that, you may post questions. Also, I'm looking at the live chat room of YouTube, since that has seen a couple of improvements over the time. You know, when I did these live streams a year or two ago, that was pretty basic, but now I feel it has slightly improved. So let's try using the YouTube chat room as well. I see Activate FPV saying, how have you been? This is Josh Law. It's just asking who you are because you have already one of these blue wrenches, which means that you are a mod in the YouTube chat room and can help me to keep things sane. Because as it turned out, as soon as this stream gets some traction, we get some interesting visitors to the chat as well. Mechubaka says, welcome to the future. And Dududu76 is there as well. We turn the Discord chat on the other window where no one has posted anything yet, but me saying, new stream coming up, please get the popcorn ready. So usually I'm doing the stream out there on the balcony because there's better light and birds in the background. But today I needed a bit more space to show you all the stuff on this table, which is a small selection of the batteries that I've used over time. Some of them are still in use, but most of them have already done their job and are just sitting at a somewhat safe place. And yeah, today I dug them out for research and demonstration purposes. So in order to show you that a little closer, I've set up a second camera so you can see this mess on my table here, and while I'm talking about it, I will pull up individual cells, batteries to show you what I'm talking about. So to start with, I'll read the text that I've written a couple of weeks ago for the Micromotor University. It goes like this. After we've covered the two important topics of RC transmitters and video receivers over the last two episodes, today we will talk about the first micro-specific topic, which is 1S, which stands for single cell lipo batteries. Now, batteries, I know that that's not a 100% accurate term because it actually means a combination of multiple things. And if it's only one cell, it's technically not a battery. But as far as I know, the English language doesn't really have another good word for that. So most of us are using batteries even for single cells. In German, it's a little different. You have different words for it. So the single cell would be a Akku, accumulator. But yeah, no one is really saying that in English. So I'm saying batteries, even though I know that it's technically not a battery, just a single cell lipo, lithium polymer. Lithium polymer technology delivers currently the highest energy density amongst commercially available batteries. That's why we're using it for flight. Single cell 1S lipo batteries have proven to be the best energy source for powering micromotors in high performance micro air models because they offer the highest density and thus the highest performance per weight. Micromotors are per definition very small and light, typically 5 grams or less. Small components tend to have difficulties with high voltages. That's why small devices tend to use single cell lipos or other single cell batteries, whilst larger devices often use multi-cell batteries to provide higher voltages for larger components. So usually if you look at the small model, it will run on less voltage than a higher model. It's very difficult to run a small model on high voltage, and it's quite difficult to run a large model on low voltage. Don't ask me exactly why, but it seems to be the law of physics. Now here's the problem with lithium polymer. It is combustible. That's why we have difficulties sending and receiving those batteries in the mail, especially internationally, after Samsung has last year produced a batch of phones that have blown up in airplanes. Things got a lot worse for this hobby and sending batteries around the world. And we also have to be careful when we're using charging and discharging, but especially charging those batteries. Because if you overcharge, overheat, or damage a lipo cell, it may start an uncontrolled exothermic reaction, a fire, and it will emit very toxic fumes. In the text for the Micromotor University, I have embedded a little video at this stage, which shows the overcharging of a 6 gram, 300 milliamp lithium polymer battery. and no, it's actually a 10-gram battery. And as you see in the video, it burns up quite spectacular. The amount of fire and smoke coming out of a 10-gram battery is quite remarkable. If that goes off in your living room, you will have a problem. So we need to be very careful in charging these batteries. And I've learned over time how to do that. I had never explode a battery on the charger because I know what to set for and what to set the charger for, and also how to spot problematic batteries and discard of them before they create a problem. Now, the other big point of danger when using LiPo batteries is, next to charging them, is when you crash them. When they get deformed and when the layer which separates the two components, the positive and the negative part of the battery, when this dielectricum is disturbed and these two parts of the battery can touch each other, they will create that same exothermic quick reaction as in the battery is puffing, smoking, burning. Luckily, with our small models, this doesn't happen that often. The propellers are not powerful enough to destroy the battery, and even if it comes down, the force of the copter pushing the battery into the ground is usually not big enough to create physical damage. So today we're going to mainly focus on charging batteries and how to test them to make sure that they're still performing good. So a few general rules, safety rules when charging LiPo batteries. Rule number 1, never charge your LiPo batteries unattended. Even if you are feeling safe and even if it has worked 100 times, you better stay close to your charging rigs so you can hear it going off, and maybe hear the alarm on your charger if it has proper safety mechanisms, and then yank the battery and put it into a safe spot before it creates problems. If you're not there and the thing starts a fire, you will not only have the consequences of potentially igniting other parts of around in your workbench, but you will also have the consequences of these toxic fumes. If you are looking at insurance cases of lithium polymer fires, a lot of the damage is not created directly by heat, but by the fumes that are emitted. They're not only dangerous for people, but they are also dangerous for everything around them. Rule number 2, educate yourself about the correct charging currents and voltages. Part of that I will cover in today's episode. Rule number 3, use quality charging equipment. A lot of RTF, ready-to-fly models come with little USB chargers, and those can be a contributing factor to problems. And on the back of rule number 3 is rule number 3B, which is test and monitor your charging equipment. Even the expensive chargers that I'm using, from time to time, or actually quite frequently, I'm taking the batteries that freshly come off the charger and plug them into an additional device, either another charger or a dedicated voltage meter, to check if they come off the charger with the voltage that the charger claims. Now there are 3 popular ways to charge 1S LiPos. The first, as I just mentioned, RTF chargers USB dongles, usually included with ready-to-fly models. Number 2, universal hobby chargers, such as this one over here. Or this one. Or this one. Now they have in common that they are universal, as in you can press these buttons, enter the menus, and then change how much voltage and how much current is supplied to the battery that you're charging. They also have in common, although this is maybe different on some generic chargers, that they do require an external power supply. So usually you would need to have some sort of 12 or sometimes 24 volt power supply to supply these chargers with the right voltage. Before we go into the details of how to use these generic chargers, let's talk a little bit about these RTF chargers. Now, I'm going to put them over here. I do have quite a collection of those. All sorts of USB chargers. They come in all sorts of different shapes, but most of them connected to USB, and then there's one output for a battery. Some of them have more outputs as well. My general advice for these RTF/USB chargers is, if possible, don't use them. They are usually made from low-cost component, and they usually have no display to show you the voltage, the current, or the capacity that has already been charged into the battery. They can also pose a risk to the USB source they are plugged into. So to play it safe, I recommend to not plug any of these USB chargers into your expensive laptop or other equipment. Only plug them into USB wall warts, power plugs, or power banks. Do not plug them into your computer, laptop, or any other expensive device. Rule number 2, do not leave those RTF chargers charged for more than an hour. If they are suited well to that particular battery, the battery should be charged within an hour. However, some of them are not terminating the charge properly, so by letting it run for longer than that, you are risking all the stuff happening that I mentioned earlier. And rule number 3, I already mentioned before, after the charge, use a voltmeter to check the voltage of your battery. If it's more than 4.2 volts, or in the rare case of high voltage chargers, 4.35 volts, do not keep using this charger, because then the end volt termination doesn't work properly. Now, I won't talk much more about RTF chargers unless you have questions later on. My main advice here is don't use them. Get a proper charger if you want to stay safe and happy in this hobby. Now, what I'm going to spend more time on are these universal hobby chargers. That's how I primarily charge and test my batteries, and yeah, that's what I'm going to spend most of the time of this video on, to go through the different options and different possibilities what you can do with those chargers. Now, if you have any larger RC vehicles, you probably already have one of these multi-chemistry, multi-purpose general purpose battery chargers that can charge a variety of different batteries. These chargers usually have two bullet connectors for the main battery connection. And a balance connector to balance multi-cell batteries. With the right adapters, you can connect multiple 1S batteries to each charging port. For example, this charger here only has two outputs. It's capable of charging two different batteries, and each of them can have up to 6 cells. Now, because when we're flying micro models, we need a lot of batteries, you can use adapters like this to essentially turn multiple single cell batteries into one larger multi-cell battery. For example, if your charger has 4 balanced multi-cell connections for charging, you could use a 6-way serial adapter on each connection to charge 24 single cell packs at once, and the charger will monitor and manage the voltage of each of those batteries individually, although it only has 4 outputs. Important. You need to know how to program your charger to charge multiple cells in parallel or in series. If you combine packs in serial, you are creating a pack with the same capacity but a higher voltage. For serial charging, you need a balance connection to avoid overcharging of individual cells. If you combine packs in parallel, you are creating a pack with the same voltage but a higher capacity. For parallel charging, you need to verify your cell voltages before connecting the packs to avoid excessive compensation currents that are basically discharging one cell and charging another and may cause some of the problems that I mentioned earlier. To learn more specifically about how to set these values, you may want to watch the serial charging, parallel charging instructional video that I have linked in the video description. I will talk more about this if you have questions, but you have basically covered all that's required in this video. But yeah, as I said, if you have watched this or if my explanations in this video didn't make sense, please put your questions into one of the chat rooms. Now, to leave you some time to post those questions and also to cover a little simpler topic, I will talk about dedicated 1S and in most cases multi-port chargers. So on one end we have these very simple RTF chargers which are as cheap as possible and their possibilities are limited, and on the other hand we have quite complicated, sophisticated general purpose chargers. However, since we're using mostly single cell batteries in our micro models, manufacturers have come up with more convenient ways to charge exactly those batteries. And I do have an example of such multi-port charger, which is also covered in my micro charging ABC, and that is this charger here. It's called the High-Tech X4 Micro multi-charger, and it's a rebrand of, I think, a Sky RC charger, which looks very similar, just has blue plastic. I also go in detail over this one in the microcharging ABC. It basically has 4 different channels where you can adjust the charging rate, and it will show you, as opposed to many of the RTF chargers, it will show you the voltage, the current, and the charged capacity. So after a battery is done, you can look at the display and see how much current, how much capacity went into it, which is a very good first indicator for your cell health. So this charger has adjustable current of up to 1 amp for each port. It has 4 ports in total. And it has quite a few different types of battery connectors. It charges the cells to only 4.2 volts. So if you have any other battery chemistry or lipo high voltage batteries, it will not charge them to their specific voltage. However, I'm using this charger to also charge my high voltage batteries. It doesn't hurt them if they're only charged to 4.2 volts. And for most of my flights, that's actually enough. The difference of a high voltage cell being charged to high voltage and being charged to only 4.2 volts is not that big. Yes, it provides a little extra performance at the beginning of the flight, but it doesn't change things fundamentally. So I'm using this thing a lot, especially in the field, because you can connect a 12-volt source, which can be either your car battery or any other 3S battery, and you can also connect it straight to the mains on the other side. So a very nice practical charger to take along and keep your flight packs charged. You can use a large battery like this here, for example, to keep this charger running for a couple of days. So instead of buying a huge amount of small batteries, you can get away with however many you need, around 8 to 16, and keep them topped up while you're flying the others. So yeah, very handy little charger. All the others, they usually stay at home. Or when I'm at home, I prefer to use those chargers because yeah, it just feels more accurate, more safe to me, and I can charge more batteries at the same time as well. There's also, I have one somewhere, but I'm very rarely using it. Tiny Whoop in cooperation with TBS, Team Black Sheep, has, I think around a year ago, released a dedicated microcharger, which has 6 outputs, and it also runs off a battery. And it charges the batteries to high voltage, 4.35 volts. However, it has no adjustable current. It has only the one PH2 connector per port, and only one display that cycles through the voltages for each port. And I've also found that it's less accurate than the X4 Micro. My batteries come off that TBS charger with more variety in voltage than on all my other chargers. It runs over 3 to 6S lipo or 12 to 24 volt power supply, and it's quite a bit cheaper, I think around half the cost of an X4 Micro. So yeah, if you want to get into this cheap, I think that TBS charger is an okay option, but yeah, I prefer more accurate gear. So that was the formal part of it to catch you guys up who are watching this, although I think for most of you being longer in this hobby, this is probably all common knowledge. I hope if you are new to this, you have learned something already. And I've just heard my time lady announce that it's 8 o'clock, which means half an hour is over already. Felt a lot shorter to me. However, I'm gonna add a few minutes at the end now to look at your comments and also catch up on any comments you might have on any other topics that I've published recently on the internets and anything else that has come up. So if you want to comment in the Discord chat or in the YouTube chat, this is your time right now. Let's pop out the chat. What's going on, guys, in the Discord chat room? There's nothing. The tumbleweed is rolling through the Discord chat room. YouTube chat is relatively quiet as well. Did all the announcing not work properly? Tell me about it, guys. Did you get a notification about the live stream? I scheduled this stream 24 hours ago, so I was hoping that YouTube is telling you about it. However, there also seems to be a weird bug in the YouTube live stream event scheduling form, because whenever I entered a date or a time, it would default back to today, now. It behaved a little different on different browsers, so yeah, there might have been some confusion when exactly the start of this stream is. So yeah, if you could comment on this, how and if you have received notifications about this, that would be nice. It's not that YouTube would tell us content creators about this. So Darex G says regards from the UK. Welcome, my friend. Dragon Ears is back to fist bump buddy. Josh says, should we share that video of your live stream fire? Oh yeah, I forgot talking about this. A while ago when I also did some live streaming about videos, one of the batteries literally exploded. Well, exploding is probably not the right term, but it started to smoke heavily in my hand. And yeah, that's just because I've done some not so smart experiments with it just prior to the stream. But yeah, that's just telling you, charging batteries can be unpredictable. So yes, please, Josh, just post it in the comments of this video in the chat or somewhere. I know that Peter made a funny GIF about this. Me jumping up, at first throwing the battery and then coming back, proudly dangling it in front of the camera. Yes, I've blown it up live. Stephen Richardson says, good job, man. I like your content. Glad to have you here, my friend. He also says, where do you live? Your backyard looks tropical. It's subtropical around here, but we live in a specifically tropical leafy part of the Central Coast, which is the Central Coast of Eastern Australia, around 50 kilometers, which is around 2.5 hours drive. Yeah, believe it or not, only if the streets are free from the Sydney CBD. Oh yeah, sometimes actually a little less. So around 2 hours north from Sydney, this is here. My neighbors and lots of people around here call this paradise, God's country. It's a quite beautiful area around here. Very nice weather, nice people, nice nature, but not hot enough for most dangerous critters. So although we do have a lot of snakes here, most of them are not dangerous. We don't have any alligators here. We do have a lot of spiders though. My yard is full of the deadliest spider on the planet. But yeah, they're more afraid of me than I am of them. Nathan Carey says, YouTube did notify me at least. Thank you, YouTube. Do76 says, do you have a clue at what improvement we could expense in the future? Maybe higher voltage lipo or replacement to lipo? I assume that English is not your first language, which is okay with me, because as some of you might have noticed, it's not mine either. So I don't fully understand your question, but I assume that you are referring to what battery advancements can we expect in the future to make our flight experience better, more powerful, longer, safer. I don't know, to be honest. I'm waiting for improvements in this space for the last 10 years. I hope that we at some point will have the flux capacitor, or just in general, high performance, high capacity capacitors. So in my dreams about the future microquads or micro hexacopters, I imagine these plates, instead of being dead carbon, being a capacitor. So instead of having this whole ground plate here, come on, go away, made out of dead material, carbon, this could be a capacitor. So 2 layers of this could be a large capacitor, which could be charged in split seconds and which could provide very high current abilities to create great flight performance while not occupying as much weight as our current batteries does. This thing requires a 20 to 30 gram battery to fly properly. If the battery could be built into the frame and it could charge in split seconds, I think that would be a great way forward. I don't know if that's going to happen. There's many battery technologies being developed in universities and in businesses, but a lot of them don't make it into mainstream because the production of those is so expensive. So I don't know what's coming, but I certainly hope we will finally have a breakthrough in battery technology, because that's what's holding a lot of mobile technology in general back at this stage. Alex Stewart says notification was fine. That's good. Concrete Snail says I didn't get a notification. I'll suggest you subscribe to my YouTube channel, and maybe you have to click the bell to get notifications. I don't really know. It's changing all the time. Sebin Sersol, sorry for probably pronouncing your name wrong, says nope, no notification. So those of you who didn't get a notification, are you subscribed to the YouTube channel? If not, do that. If yes, press the bell and tell me if that changes anything. Nathan says there are a few more 1S chargers out there now. Horizon Hobby have one that I have, and Hobby King have one that has a decent single display, multiple connectors, and 4.35 volts. Yes, I've seen a few of those. Many other manufacturers are catching up. So usually, if you only want to charge 1S lipos, those chargers are a very good budget option. JBFPV is asking, have you ever had a lipo randomly puff or catch fire whilst sitting at storage voltage? I had one puff at night. Luckily, I keep them in a small safe. No, well, randomly puff, yes. Randomly explode, no. So, randomly puff, yes, they do. So, as some of you know, I'm not only keeping a lot of batteries for my own purposes, but also I resell batteries. So a lot of them that are sitting in storage for a long time, they get problems over time. So here, look at this, for example. Boris, if you're watching this, I'm not picking intentionally on my lipo. It's just that that most of the batteries I have are my lipo, and those are also those that I'm not mistreating so much. So this battery here has never been used, but it has puffed already. So as you can see, sorry, it's not focusing here, a little further out here. As you can see, the seams have already expanded a little bit, and when you press on the battery, you feel that it's soft. Now this happens to a certain percentage of all lithium polymer batteries. When they come from the factory, depending on the quality control that the factory is doing, when you get those batteries as a vendor, then in my experience, a certain percentage of them will puff eventually. So in my position, me wanting to send out only good batteries to my customers, what I do is I just store them for at least a month, and then before I send them out, I look at them. If they are puffed, they get discarded. If they are not puffed by just sitting there at storage voltage for around a month, then the chance of them puffing up later is reduced a lot. So a certain percentage of them, I would estimate on those batteries that I'm getting maybe 2 to 4%, they will puff just by sitting there. So I let them sit there and then weed out the bad ones and only use and sell the good ones. Now, if you're buying batteries from a batch that has not been stored or not been checked by the vendor, it's very likely that you get the battery, and even without using it, just by having it sit there, it will develop problems over time and puff up. Now, puffing up is just a symptom of problems in the battery, and puffed batteries always perform worse than batteries in a proper state. So if it's puffed like this one, you can pretty much guarantee that it will not perform properly anymore. And if a battery already has problems but it's not puffed, and you are charging it or discharging it towards its current limits, it will start puffing up as well. So on many batteries that are still somewhat okay, if I discharge them at their maximum current rating, some of them puff up temporarily. Now, if that's only a little bit, and if it's only temporarily, it might not affect performance too much. But if it's puffing up permanently by just sitting there without being charged, without being discharged, and without being heated, then you can safely assume that that's a bad battery. What I like to do with them is put them back in their bag so that the connectors cannot touch anything else, and then I chuck them into a safe, which in my case is a vented ammo box. I've drilled a hole into the side of the box here and put like a plastic fitting in there so it doesn't cut the wires, and then I sometimes also charge batteries in there to verify that they're still good, and I don't want to risk me burning myself when yanking them and throwing them. I have the wires coming out at the side here. I'm closing the lid and then I'm charging it, and if anything happens, smoke comes out of this hole, I just yank the connection, which will have a connector right out here, and then this thing has a handle so I can throw it as far as I can down there onto the concrete. So yes, I have a lot of puffed batteries, Jelle, and very few exploded batteries. But yeah, puffing batteries is the first sign of them developing a problem, and if they're puffed, you should stop using them. I've seen some strange experiments on YouTube where if you have a puffed battery like this, see, it already kind of looks like it's under tension and it's soft. I've seen people puncturing them to kind of let out the pressure. I don't know if that's a good idea. So, debate the cause number 3 says, I'm subscribed. As soon as I saw you were live, I came straight in, working for me. Ring that bell. Okay, another indicator for that you need to press the bell if you want to get notifications. Sabin says, I'm subscribed for a long time. Thank you, my friend, and the bell is active. Did you say before no notification? I don't know what to do about this. Drone On says, you get notifications. That's good. So, no messages in the Discord live chat. Do you guys don't like that chat anymore? I mean, there was very little participation previously as well. If all of you are happy with the YouTube chat, we can continue using just that as well. I have a quick look into the Facebook posts that I've put up. Oh, there's not much going on here either. So Jeff Trockman likes my post, but didn't say anything. Yeah, I'm still kind of on the fence with my opinion about these notifications. I think quite a few more people are actually interested in this topic, and I also think that this time right now is actually a good time for more participation. So I'm not really sure why the chat influx is so low. I appreciate all of those of you who have commented, and if you like the content, I invite you to share it around, to subscribe to the YouTube channel, to subscribe to the Micromotor Workshop podcast, and share it with your friends so we can accumulate our a little larger crowd, needs to be a fine balance. As we've seen 1.5 years ago, if the live crowd gets too much, then it's pretty difficult for me to catch up with the chat room. But I think at this stage there can be a little more to keep us all entertained here and to keep the questions coming to make sure that I'm not missing anything. JB says, thanks for the explanation. I thought puffed batteries could catch fire. I assume they can. I mean, puffing is certainly an indicator for problems, but I can also report I have puffed batteries sitting here for a long, long time. I only ever go to the battery throwaway place when the little ammo box is full. So yeah, I have it sitting here with puffed batteries for quite some time, and them just being puffed is not a problem. In general, the energy that a battery can, what's the right word for this, can emit is directly related to how much energy you have put in before. So if you take a battery that sits there at storage voltage and do violent stuff to it, like for example, driving a nail through it or turning it through a grinder or hammering it flat or whatever, the reaction you get out of this is directly related to how much energy is in there before. So a charged battery will react a lot more violent than a battery at storage voltage. I have done this for my own research purposes because in this room up here, I'm storing a couple of thousand batteries, and I don't want my battery storage to blow up because up over there, me and my family are sleeping and living. So I want to be absolutely sure that this place doesn't burn up. And I have similar, you can't see it because it's so dark in there, but you can see over there at this side of the screen, you can see some of these tool chests that I'm using. They're made from pretty solid sheet metal, and if something in there starts burning, it will not burn down the house. It will only start smoking like crazy, and there and there and there and there and there and there are smoke detectors which make a whole lot of noise very quickly. So even before you see smoke, these, I don't know, they have some radioactive symbol on them. Even before you see smoke, they already make a lot of noise. They're connected to the main power system, and they have a backup battery. And then I also have a fire extinguisher for chemical fires in there. So I think that's keeping me safe. But as I said, most importantly, don't store them charged. That's what's providing the energy for violent eruptions. So if you drive a nail into a charged battery, the reaction will be much more violent than when you do that into a battery at storage voltage. So the reaction you get out of a battery at storage voltage is kind of boring. So if you punch a nail through this thing while it's fully charged, you get a lot of smoke and maybe also enough heat to ignite other things. If you drive a nail through such a small battery at storage voltage, it will barely get warm and emit just a little bit of stinky fumes. So one more reason to not store your batteries charged. However, the main reason in terms of performance is that if you keep those batteries charged, they will also lose some of their capacity, some of their discharge ability. So you can imagine, for many purposes this makes sense, you can imagine batteries as a balloon. If you have them at storage voltage or completely discharged, it's an inflated balloon. Now, it's a deflated balloon. Now, if you discharge the battery completely, it's like the balloon is shriveling together and the two ends or the sides of the balloon are sticking together, and then you can't blow it back up again. Now, this is not actually what's happening, but that's an analogy that maybe helps some of you to treat your batteries properly. If it's at storage voltage, it's blown up a little bit. It still has some air, so it doesn't develop these sticky problems. But if you would poke a hole into it, not much, no huge bang is happening, just a little bit of air is coming out. If you want to use that battery, if you want to put energy into this, you blow up the balloon and then it's under tension. So that can create problems because now there's a lot of energy in there. If you poke a hole into it, it creates a bang and might destroy or scare people. And it also will make the material wear out over time. If you blow up a balloon, it will stretch it and the material would get porous and eventually the air will go out. And if you have left it blown up for a long time and then use it again, the force coming out of this is not as big as if you would always let it deflate again. So treat your batteries like a balloon, only keep them at storage voltage and only blow up just before you want to use them. So that's one of the reasons why you want to be able to charge many batteries at the same time. I usually use for a flight session, I use between 8 and 16 batteries, and I want to charge them up as short before my my flight session as possible. So usually I come down here, I work for an hour, and when I want to fly afterwards, I put my batteries on charge before I start working. And then when it's time to fly, they're all charged up and I make sure that I go through all of them. So I have these little discharging devices. They look like this. They have 4 motors and 4 propellers, and I use them to discharge my batteries. So sometimes they break during a flight session, so you need to have a lot of backups of these, so you can make sure all your batteries are discharged properly. Main safety advice: don't leave your batteries charged. Exactly, JB. Try discharging them. So I have arrived at the end of the chat room and it's already 8:30, so we have a good hour of stream and podcast. Well, I probably will cut out a little bit of the stuff that didn't work at the beginning. So, there's another message coming in. Hey there, says Bear FPV. Just had a whoop race. That's good. Thank you for your support with our chapter. Everyone is very grateful for your help. Video in the works. So, yeah, I'm supporting quite a few whoop or micro racing leagues around the world. I'm glad you appreciate that, and I hope this video helps you a little bit to keep your batteries charged efficiently and safely. Thanks everyone for watching. Specific thanks to everyone who has participated in the chat here. On the next stream, I would appreciate if you guys, when you see the notification, that you can post that on your various social media accounts to get a few more bumps on the seat in the chat room here. That would be most appreciated. Thanks everyone. I see you on the next one.